Hi everybody, my name is Diego and welcome to the TRIAF channel. Today we are going to see how to apply machine learning to technical analysis. Now, in particular, we are going to use the minimize algorithm. That is an algorithm that can be found in the Tensorflow Math package to optimize the ATR Trailing Stop technique. So this is a very common technique used in technical analysis, and its purpose is to identify trends in asset classes. Now, this is one of my first video, so it's not going to be exhaustive, but it will be enough to grasp the potential that machine learning can have in finance. Now, to have an understanding of how the algorithm works, we need to know how the ATR works. And if you know that already, I will leave a link in the description to jump straight to the code part. If you don't, follow me. So the ATR stands for average true range. So first we need to compute the true range. The true range is a measure of volatility at a specified time. So say for every candlestick, we need to calculate three things: the current high minus the current low, the current high minus the previous close, and the previous close minus the current low. Once you do that, you select the maximum of them, so we will have a single value for every candlestick. At this point, we are ready to calculate the ATR. The ATR, so the average true range, is a measure of volatility over a certain time period. It is a function of the true range and n, the time parameter. Now, let's have a look at the formula. So the ATR at time t is equal to the ATR at time t minus 1, so the previous ATR, times n minus 1, plus the true range at this time, at the current time, all divided by n. Now, this is a kind of exponential moving average, and it is regulated by n. So this n represents the time horizon you are going to consider. I will show you an example later, but as an idea, you can think about it in this way. The higher n, the smoother will be my ATR function. Okay. Here we have 6 or 7 months, maybe, of the Standard & Poor 500. Okay, so here you have the chart with the candlesticks. Here you have the true range. The true range, as you can see, oscillates quite a lot. Now, the average true range for a time parameter of 15 oscillates much less. And even less, the average true range for a time parameter of 115. So as I said before, the higher my n, my time parameter, the smoother will be my ATR. Okay, so here we have the very same chart, but I added the trailing stops. So you can see two lines, basically, the green one and the red one. So please note that the green one is always below the candlesticks, and the red one is always above. But how are we going to compute the values to give to these lines? Well, this is the formula. So the ATR bands are calculated like the close price of the candlesticks, plus or minus m times the ATR. In this case, m is a multiplying factor that multiplies the ATR. Now, in this case, we use a time parameter of 80 and a multiplying factor of 3. Now, let me show you that for the green line here or here, so every green line, every line that is below the candlesticks, we are using the minus sign in the formula, and for the red lines, we are using the plus sign in the formula. Now, let me also tell you that let's have a look at the M parameter. So M represents how far away from the candlesticks you want to put the trailing stop lines. So in other words, in this case, we had an M value of 3. So this is 3. Sorry for my writing. Now, in case I don't know, I choose 5, this line, this green line, would come down here, right? So more or less having something like this. The red line, instead, for an M value of 5, will go here. So the higher my M, the farther will be the trailing stop lines from the candlesticks. Okay, so now you are ready to understand how to trade with this strategy. I'm using plus 500, not because I recommend it, but because it's nice and easy to see how the ATR works. In this case, we have again the S&P 500, and what do you have to do? You have to stay long every time you see a green line, and go short every time you see a red line. Okay, so let's start from here, from the left. So suppose here you are long, you stay long for the whole time of the green line, but then here in this point you will have that the close price of this candlestick goes below the green line. At this point you close your long position and you short the asset. We say that you close and revert your position, and then you stay short until the close price of one of the candlestick goes above the red line. At this point you close and revert, so you close your short position and you open the long position, and then you keep on doing that until the end. Okay, so you could ask me, how do I optimize this strategy? Here we used a time parameter of 40 and a multiplier of 3. Those are values that were randomly chosen. And how do I optimize those parameters? Well, that is the job for our code. So now it's time to go to the code. And here is my code. Please note that we are in Google Colab. It's a nice platform. I really recommend it because in Google we trust, right? It's for free, it's online, so you don't have to install anything. You can just log in with your Google account and go for it immediately. And it's very useful. Anyway, I will leave a link in the description for you to download the code. So I will not explain every single line of the code because you can read it yourself, but I will point out the most important one. Okay, so let me hide something we don't need. Okay, so we have 5 points. First, we import the libraries. Then we import and manipulate the data. Then we define the profit function in TensorFlow our profit, cash. Then we optimize the ATR, and in the end we analyze the results. Okay, so the first point, we import the libraries. Is nothing nothing fancy, Matplot, Pandas, Tensorflow, something to control the time and the date time of our data. We also use Y Finance, that is an API to download the data from Yahoo Finance. Okay, so the second step is to import the data. Okay guys, so in order not to get lost, I will highlight the code that is necessary to understand, and then you have the file, you can go through the code yourself, but stick with me with the most important things. So now I'm setting the ticker that is used by Yahoo Finance to download the data. In this case, I'm setting the ticker of the S&P 500 future. Then I am downloading the data here with this line. Stock.history downloads the data, the historical prices for the S&P 500 that I specified in the line above. At this point, I'm going to make some pre-processing of the data. That is very important, but nothing fancy. So I will skip it and leave it in the file so you can read it. Okay, now it's time to define our profit function. So basically our return on the trading that we are doing using the ATR technique. Now, in this step, we are just initializing the variables that are used by the function. So it's just a statement to say, hey, this is the closing price, this is my high, this is my low, and whatever is used in the ATR function. After this preliminary step, we are going to define the function itself. Now you will find two functions here, the first and the second. At the beginning, run the first one. The second is to test the results. So I'm gonna open this function. This function is a very long function. Not going through every details, but have a look at this. So first of all, you can read at tf.function. That is the code to define that the following function is decorated in TensorFlow. So basically it is a TensorFlow function. TensorFlow, that is our machine learning algorithm, machine learning package, the platform on which we are building our machine learning algorithm, can use the following function. And then we define the function as if it was a normal function. So I called it test_fn. And this function is using the high price, the low price, the close price, D, N, and M. Now, N and M are the two parameters of the ATR technique. D is the time parameter of the moving average function that is used as fails signal detector. Let me explain. The ATR function tends to generate a lot of fails signals. In this case, we are using a moving average in order to drop some of the fails signals that can be generated by the ATR. And as you can see, here. Here we are computing the true range, then we are computing the ATR. I'm not going into it, but the basic idea is that we are doing exactly what I explained in the first part of this video. The only, say, peculiarity is that in this case, given that this is a TensorFlow function, we have to use matrix algebra. So it's a bit more complicated, a bit more long, but that it's needed by TensorFlow. Now I show you why I'm not going in every detail of this function, but in the end, this is what I will get. A return, ret underscore tot, is the total return I get from shorting and buying the asset, the index in this case. So at the end of this function, I will get a return that can be positive, can be negative, I don't know, but I will get a single number. We will try to maximize this number. Those are other functions that are needed within the main function. Okay, I will skip all of that. Okay, so here in the fourth step is where the optimization kicks in, where the algo goes live. And here I am defining it. So have a look at this. I defined the trace function. So what to trace during the training of the algorithm. In this case, I stated to trace three variables, x1, x2, x3, so my d, my n, and my m. So the time parameter of the moving average, the time parameter of the ATR, and the multiplying factor of the ATR. Here I'm defining the loss function. So what to minimize. And in fact, the loss function uses a Tensorflow Math package, minimize algorithm. And here I wrote that the loss is given by the negative of the test function. Now, why the negative of the test function? Because there is only a minimize algorithm and not a maximize one. So if you remember, the test function gives me the return, the total return of my trading activity. So I will have minus the total return, I will minimize it, and so I will maximize the total return. Okay, going forward, I declared that the optimizer is Adam with a learning rate of 0.1. Now I think Adam is one of the most used optimizers in machine learning, so that's why I used it. Here I'm declaring the variables that need to be trained. In this case, I'm declaring that only x3 will be trained. X3 is my m, my multiplying factor. Why only x3? Well, I have to admit that I tried to optimize more than one variable, but it didn't work well. So I don't know why exactly, but I think either my code is not robust enough to handle more than one variable optimization, or it's the minimize algorithm that is not very well designed for more than one variable. I don't know, maybe both, I don't know. But anyway, I'm training the most important variable, that is the multiplying factor, because the other two are the time parameter of the moving average and the ATR. and I can set those simply considering what kind of trading activity I want to do. So if I want to trade more often, I need a time parameter that is lower. If I want to be more steady and trade less frequently, I set a time parameter that is higher. Okay, here I'm defining the convergence criterion that is based on a relative tolerance. What does it mean? It means that, as you might expect, our loss that we defined earlier keeps on decreasing during the training. Once that decrease is smaller than the relative tolerance that I set to 0.5, the training is stopped, and the last result is the best result. Okay, here are some other parameters that need to be defined, and in the end, one of the most important is the number of steps, so the number of iterations that we want to perform during the minimization algorithm. So I'm going to run this cell. This is running. Okay, now it has finished in 53 seconds. That was okay. For you, probably it was less. Okay, now I want to analyze the results with you. Okay, so what do we have here? Here we have a table showing that, so as I said, D, N, and M, and our return in percentage points. I set D and N to 100, and the algorithm was playing with my M parameter. So at the end, after, I don't know, 58 steps, we got an M parameter of 9. Let me show you what happened here. Okay. This is a chart. We are plotting our return here. It looks linear, but probably it's because I have chosen a very high multiplying factor at the beginning. So I initialized the multiplying factor with a very high value. And then, of course, the algorithm kept on decreasing it until we saw some non-linearity here. And here, interestingly, we have found a maximum of the return function at the 57th iteration. Nobody is granting us that this maximum is the global maximum of this function. Nobody. But it's one of the maximums that we can find. Before plotting the results, let me show you that we had reached the local maximum at the 57th iteration, right? So if we go back, the 57th iteration had an M parameter of 9.1. So this is the value that we are going to use to plot the results. Okay, so now I'm plotting the results. I have already run the second version of my test function. So the second version, if you go back to your code, was made for testing purposes. I am defining the three parameters I need. So 100 and 100 are arbitrary values. 9.1 instead is the value for which I have reached the maximum in my return function. And then I simply run this cell. So I have the results, and then I plot them. And as you can see, this is our final goal. So we are done, more or less. All right, so the algorithm tried to gain as much money as possible. It first went long, then short a bit, then long again, short, long, short, very, very long in the end. It looks nice, but remember, this is a backtest. We should now test the algorithm with new data. I'm not doing it right now. This is the end for this video. The code was far from being optimized and from being perfect, but still it was enough to show you the potential that this technology has in finance, and in particular in technical analysis. Okay, this is really the end. I hope you liked the video. I honestly don't care if you subscribe to my channel because I'm not getting any money out of it. But if you want to do something more useful, please provide some feedback in the comments on how to improve this code. And if you want, share some ideas on what you would like to see on my channel the next time. And see you to the next video.